Hello students, in this video let us discuss work done and some formulas related to work done in different type of processes. So let us see what is work done here first. So work is said to be done if any object displaced through a distance dx against a force F. So I repeat again here. Work is said to be done. For example, if any object is displaced through a distance dx against a force F, that is said to be which one work is done. So now work done can be written as here against that force means force into that distance moved is L. And we know the formula for force, which one here? Pressure into area and also this L value. And what we can get here? Pressure into that volume, or we can consider that as a change in volume. So now that means here work is nothing but product of the external pressure and which one here? Change in volume. Now that can be written as, how we can write that work done expression? See here, work done expression is against an external pressure, now change in volume delta V. So this is the expression for which one work done. Here P external means this is the external pressure and delta V is a change in volume. And here units of work done here we can get in liter atmosphere. But work done is also expressed in different units. What are the different units? Means here joules, ergs, like that. Then we have to write the relation between which one here? Liter atmosphere and joules. Because sometimes the question they give related to work done, but they give the options in which one means here joules. Of course, by using this formula, we are getting work done in liter atmosphere. So 1 liter atmosphere equals to 101.3 joules. So now to convert liter atmosphere into joules, we need to multiply with 101.3. So this is the formula to calculate work done. And one more important thing here, work done on the system. Work done on the system is which one? Means positive. Work done on the system. Work done on the system is positive. And another one here, work done by the system. Another important thing we have to write here. What is that? Work done by the system. Work done by the system is negative. So we have to remember these two important points here. Work done on the system is positive. Work done by the system is negative. Now here different formulas are there to calculate work done. That depends upon which one? That depends upon reversibility of that process and irreversibility of the process, and depend upon the process different formulas are there. Let us see what are the different type of process here. The first one is here isothermal process. In isothermal, either for expansion or compression, we have to use this formula, either isothermal expansion or isothermal compression. In that condition A, if the process is reversible, now we have to use the formula W reversible equals to minus 2.303 nRT log V2 by V1. Sometimes instead of initial volume V1, final volume V2, they may give initial pressure and final pressure. At that time the formula is minus 2.303 nRT log P1 by P2. Because pressure and volume both are inversely proportional now. So P1 by P2 we have to write. Now this is the formula we have to use for isothermal either expansion or compression under reversible conditions. And if you go for irreversible, that means here in irreversible conditions, what is the formula we have to use means here W irreversible equals to minus P into delta V or change in volume. So these are the two formulas we have to use for which one, that isothermal expansion or compression. And now another one here, adiabatic. Second condition is here adiabatic expansion or compression. Here also both the conditions we can consider either expansion or compression. In that first process is here reversible. If the process is reversible, work done is equals to NCV delta T, where N is the number of moles, CV means heat capacity at constant volume, delta T means change in temperature. And in this, irreversible means as it is, like in the previous case, what is that work done is minus P external into delta V. So these are the formulas to calculate work done in isothermal and adiabatic expansion or compression, and also in case of reversible and irreversible. And one more important thing here, work done in vacuum, that means free expansion or free compression, whatever it may be. Work done in vacuum is, we have to remember that is zero. Work done in vacuum or work done in case of free expansion is zero, because in vacuum there is no external pressure now. That means if external pressure is zero, zero into whatever the change in volume, that also becomes zero. So work done in a free expansion or in the vacuum is taken as how much means zero. So now then we have to go for another type of problems related to work done. What are another type of problems? Sometimes graph related questions one may get here. What are the graph related questions means? They give P versus V graph, and of course they give the values here. This is 0 and here 10 atmosphere, 20 atmosphere, this is 10 and here 20, like that. They give the values. Now the question is here, what is the work done related to this graph? So whenever that graph related type of questions are obtained, just we have to answer like this: the area under the curve is taken as which one work done. Now depend upon that graph. For example, if a square is given, we have to use the formula, which one, area formula for a square, to calculate the work done. If a circle is given, we have to use the formula of area of circle to calculate work done. So like that here, area under the curve is taken as work done. Okay, now sometimes they may give here circle or whatever, square or rectangle, whatever it may be. But if they have given like this clockwise, now the question is here, this graph indicating, now options they give: work done by the system, work done on the system, no work is done on the system, no work is done by the system, like that. If clockwise symbol is given, we have to say that work done by the system. For suppose, if anti-clockwise is given in this P versus V graph, if anti-clockwise is given, that is said to be work done on the system. So how to remember means very easy to remember. For example, clockwise direction means we know that in our wall clock, now we can see the movement in clockwise. That means here they that in the wall clock we can see the movement in which side, clockwise direction. Of course we are not applying any force to move in clockwise. That means of now that work is done by the system only. But if you want to set the time, now sometimes we have to move that in anti-clockwise direction also, but that is possible when we apply some force on it. That means anti-clockwise, if you want to move that in anti-clockwise direction means we have to apply some force on that. That means we are doing work on the system. So like that you have to remember, clockwise means work done by the system, anti-clockwise means work done on the system. Okay, now here this is regarding which one, graph related questions. Now let us see a small question related to work done here. So what is that question means? For example, a gas is now against 0.5 atmosphere pressure. Now that gas is compressed from 400 ml to 200 ml. A gas is compressed from 400 ml to 200 ml against a pressure of 0.5 atmosphere. So what is the work done here? So now let us see what is the formula. That work done equals to minus P external into delta V. Minus P external means here 0.5 into delta V means here we have to consider that volume in liters because the work done units here liter atmosphere. So we have to change the milliliter into liter. Now liter means here this is 0.4 liters, this is 0.2 liters. So delta V equals to 0.2 minus 0.4 minus 0.2 liters. So minus 0.2 minus of minus plus, what we can get here means 0. Okay, this can be written as which one here, 5 into 10 power minus 1. This can be written as 2 into 10 power minus 1. So we can get here which one, 10 into 10 power minus 2 liter atmosphere. We can get that value. Now what we have to do this to change into joules, multiply with 101.3. You get that answer into which one here, that joules. That means here this will give how much, 10 power minus 1. And to convert this into joules, multiply with 101.3 means we get 10.13 joules. So this is the work done here. So now as a positive we got here work done. This is indicating what, work done on the system. So that's why only when work done on the system, what happens, volume decreases. So that's when volume decreased from 400 ml to 200 ml. So these are this is one type of a problem related to which one here, work done. Okay, now after this let us go for which one, thermodynamics first law. So what is the first law of thermodynamics? First law of thermodynamics. Let us see here. Of course, zeroth law is also there. Zeroth law means very simple, nothing that one. If A is, that means A and B and C, three systems they have given. If A and B are, that means having same, that means which one, isothermal to with one another, and B and C is isothermal to one another, A and C also isothermal to one another. If A equal to B, B equal to C, therefore we can get A equal to C. So that is not much more important for us, zeroth law. Now come to observe which one here, first law of thermodynamics. According to first law of thermodynamics, what is that means here? Energy neither can be created nor can be destroyed, but that only can transform from one form to another form. So listen here again. According to first law of thermodynamics, the heat energy or any type of energy neither can be created nor can be destroyed, that only can be transformed from one form to another form. So we can call this as, we can say this as which one? Law of conservation of energy. So energy neither can be created nor can be destroyed, that only transform from one form to another form. And according to first law of thermodynamics, it is impossible to construct perpetual motion mission of first kind. What is that? Perpetual motion mission of first kind. So this is not able to prepare. What is this mission means here? This mission will do the work without consumption of any energy. For example, if you consider any AC or any fan, by consuming electrical energy, they will do the work or they will create the work. But without using electrical energy, if any fan or any AC is doing some work, that type of mission is said to be perpetual motion mission of first kind. And another one, if we fill with petrol, then only any vehicle can move. But without using petrol, if we are able to move any some vehicle, now that type of mission is said to be perpetual motion mission of which one? First kind. That means in a simple language, without anything, if we create something, that mission is known as perpetual motion mission of first kind. That means here in a institute, zero number of students are there. Even though if that institute is creating some ranks, 1 1 1 2 2 2 ranks like that, that type of mission is said to be perpetual motion mission of first kind. So without electricity, if that produce mechanical energy, or without electrical energy, if that produce heat energy, without anything, if that create many things, that type of mission is said to be perpetual motion mission of first kind. But it is not possible now. So thermodynamics first law is saying that if you want to produce some work or if you want to produce some energy, some another energy should undergo consumption, then only we can see the production of another type of energy. And another important thing here, the energy given to the system is equals to the sum of the work done and change in internal energy. Heat energy given to a system is equal to the work done and change in internal energy. So this is the formula based on, we can write based on which one? First law of thermodynamics. Q means heat energy given to the system, W means work done, and delta E means change in internal energy. So for example, if we want to warm up milk here in a container, if you warm up milk in a container, for suppose if 60 joule heat energy is given, now first container will absorb some 10 joule of heat energy, remaining 50 joules is used to do the work done. That means here the heat energy given to the container, in that some 10 joules of heat energy stored in the form of internal energy, and the remaining 50 joules used by the milk to warm up, that is work done. So like that, Q equals to W plus delta E. But so many students will get confusion regarding answer to this type of question. Let us see one question here. What is that? For example, 100 joule heat energy given to a system and 60 joule work done by the system. 60 joule work done by the system. Now what is the change in internal energy? Just ignore the formula. We have to apply simple formula here instead of this one. What is that? 100 joules energy given to the system. But the system done some work here. How much work is done? 60 joule work done by the system. If a system is doing work means it loses that much of energy. Means out of 100 joules, now 60 joules energy used by the system to do the work. Now what is the remaining internal energy? Means 100 minus 60, 40 joules. This is delta E. No need to substitute in the equation because you may get whether we have to use here minus or plus like that. No need to worry about that. But the same question, 100 joule energy given to the system and 60 joule work done on the system. 60 joule work done on the system. If the system do the work, if the work done by the system, it is considered as loss of that energy. But 60 joule work we are doing on the system means what happens? It gains that heat energy also. Now change in internal energy. This 100 already we have given. Now extra 60 joules also added. Now what is that change in internal energy? Means 160 joules. So that's it. So I give another question related to the same here. Listen to that. What is that here? For example, 60 joule heat energy given to the system and 20 joule work done by the system. Work done by the system. Work done by the system means that we have to consider it as loss. That means from 60 we have to remove 20 joules. Now the net change in internal energy is how much joules means? So 40 joules. If the same question given like this, 20 joule work done on the system. Now we have to add this 20 to 60 because when we are doing work on the system, some heat is generated. For example, if you rub the hands like this, what happens? Some heat is generated. Like that, work if done on the system, this heat is generated in the system. So now the change in internal energy, 60 plus 20 means how much we get? Means 80 joules. So like that, we can answer such type of questions. No need to use this formula because related to some other subjects, work done by the system is something they can give positive like that. So don't worry about that. We have to use this formula. Just we have to see the formula. No need to apply here. Just work done by the system means remove that heat energy. Work done on the system means add that heat energy to the given heat energy to get total change in internal energy. Okay, bye.